In this lesson, we're going to talk about defining imaginary numbers. An imaginary number is part of what we call a complex number. And a complex number looks like this, where this term is our real number. So that's fractions, decimals, square roots, pi, positives, negatives, most things that you think of. This piece is known as our imaginary number. And an imaginary number can also be called a non-real number. And it really just comes from one thing. It really just comes from this fact right here. If you square root a negative, which we can't do, so the best that we can do is we write it as an I. All that I is it represents the square root of a negative. So, for example, if you see the square root of negative 4. The square root of negative 4, we can't square root the negative, so the best that we can do is symbolize the square root of a negative with an I. We can't square root 4, which is 2, and then we attach an I to it representing that we're square rooting a negative. And that's it. So if we square root negative 25, that just becomes 5i. If we square root negative 20, okay, negative 20 is not a perfect square. Let's make these stand out. So square root of 20 is not a perfect square. Doesn't mean we can't do anything with it. We can break off the largest perfect square we can from the 20, which would be the square root of negative 4. So this is a perfect square. This is what's left over. So we can rewrite the square root of a negative 4 as 2i with the square root of 5 at the end. Okay, so that's a little bit of simplifying and how we deal with square roots of negatives, and we represent the square root of a negative really just as an I. So there's also a thing that we're going to talk about. It deals with powers of I. So I's are kind of treated like variables, but not totally, because they do represent something other than a variable. They represent the square root of a negative. So an I is just really dealing with the square root of a negative. But you can have multiple i's. So you can have I squared, which is really just an I times I. Well, because they mean something, they represent an actual value, then we can start to do some math with them. So I squared really is the square root of negative 1 squared. So square roots and squares cancel each other, leaves you with the base, which is negative 1. So we have an I, and we have I squared equals negative 1. I cubed. I cubed, we're going to try and break this up, simplify it a little bit. We could break I squared, and I is what we can break I cubed into. So we're going to add the exponents together, but we're going to break it into I squared because I squared does simplify to something that's pretty nice. So I squared is negative 1 times I is going to get us a negative I. So I to the third equals negative I. I to the fourth. I to the fourth, we're going to break into two of those. I squared times another I squared, because I squareds work out pretty nice. So that's a negative 1 times another negative 1, which makes positive 1. So actually I fourth just became the nicest. Any I to the fourth is always going to become just a positive 1. So I to the fourth is 1. So I to the fifth. I to the fifth, I would like to try and take as many I to the fourths as I can out of it, because every one of those will just reduce down to 1. So I to the fourth times I is the same thing as I to the fifth. So that's going to become 1 times I, which is just I. So I to the 5th is equal to I to the 6th. We can break it into I to the 4th again, and an I squared. Those together make 6. I's all multiplied together. I to the 4th, again, is always the nicest group that we can take out of it. So that's a 1. I squared is a -1. So that multiplies to -1. I to the 6th equals -1. I to the 7th. We can break into I to the 4th, I to the 3rd. I to the 4th is 1. I to the 3rd we add up here as a -I. So times a -I. So it really just becomes -I. All right, I to the 8th. I to the 8th is going to work out very nice because really it's just two groups of I to the 4ths. So I to the 4th times another I to the 4th. So that is just 1 times 1, which is 1. So I to the 8th equals 1. So really there's just this pattern. So we went from I, -1, -I, 1, I, -1, matching, -I, and a +1. This thing just recycles itself through over and over and over and over again, and this is the pattern that we have going on. So if we start to get to some pretty big exponents, let's say I to the 21st, our goal is to try and simplify this down. We just want to figure out where we are in the pattern, which really every 4th recycles itself through again. So we want to figure out how many I to the 4ths, or basically get to the closest I to the 4th we can of 21. So divide by 4, or find the closest multiple of 4 to 21. So I to the 20th is just a repeat of a bunch of I to the 4ths. I to the 4th, I to the 4th, there's going to be 5 of them. So I to the 20th is just somewhere along this I to the 8th, I to the 4th pattern, and it's really all about what you have left over. So I to the 20th is 1, so now we're sitting at that point in the pattern, but times an I. So we are going to be 1 further. So we start back over at the beginning. So that becomes I. All right, so if we go, let's say, to an I to the 35th. So an I to the 35th, we just try to figure out multiples of 4. What's the closest we can get? 32 is the closest we can get. It's all about what's left over, though. So I to the 32 is just a multiple of 4s. So that's just going to be a 1. I to the 3rd is -I. -I. So we are at that spot in the pattern because we are at I cubed. And we'll do one more. I to the 92nd. I to the 92nd is actually a multiple of 4. So it is just 1. And that's it. Now, most likely you're not going to have to deal with exponents this high. Very, very common, though, as some of the stuff that we're going to do with simplifying some of the complex numbers and imaginary values is we're going to have i's and I squares pretty common, maybe every once in a while an I cubed. So those are the ones that you really want to keep in the back of your mind. As some of the numbers and the exponents get higher and higher and higher, it just ends up being a repeat of the I to the 4th. So you just got to figure out where you're at in the pattern, and then you have your answer. So that was defining imaginary numbers.